Hello everyone! We are going to solve this given oblique triangle. But as of the moment, we don't have any figure, but we are given with the specific values. In order for us to solve any oblique triangle, we need to identify the given measurements so that we could decide whether we use the law of sines or law of cosines in solving for the oblique triangle. When we say solving oblique triangle, that means we need to solve or find the measurement of the remaining parts of the triangle. Here, we are given with one angle. We are given with two side measurements. But it's very important as well to look into the notations that are used. Some of you might say this is SAS situation, but when you look at the given situation, we have here a specific pair of measurements where measurement of angle B is given and side B is given. You can only say that this is SAS if the side B is side A, or it's the angle B that is angle A. In short, no other pairs of angle measurements can be given. So this is better yet known as SSA oblique triangles. But for SSA oblique triangles, there is one important task that we need to remember before we can solve the oblique triangle. That is to make sure the number or the total number of triangles that can be formed using the following values. We have specific situations to that, but focusing on what is given, since the measurement of angle B is acute, then angle B is acute. There can be one, there can be none, or there can be two oblique triangles that can be formed. If the measurement of a given angle is obtuse, there are only two possible situations. There could be one or there could be none. Now, since angle B is acute, we need to determine the relationship between A and B. Between the sides B and C. Side B is the opposite to your angle. So we need to look at the relationship of the two. If side B, which is the side opposite angle B or the given angle, so if this is angle A, that would be side A, is longer than the other side, this is the time that we can say that there's only one oblique triangle that can be formed. That is the given situation. If the measurement of the given angle is acute and B is greater than C. But if B is less than C, there can be 2, 1, or 0 depending on the situation. But because this is what is given, we are now sure that there's only one given oblique triangle. And as for this, we are going to use the law of sines now. So the law of sines will involve the ratio of a specific angle to its opposite side. So without constructing our triangle, we can actually solve for the unknown measurements of the given oblique triangle. So let's just try to substitute all the values here. So we have sine A, which is still A, over A, which we don't know the value of that, is equal to sine B is 14 degrees over 7. Let me increase this portion here for more possible computation. And you have sine C, to which we don't know the measurement, to be over 5. But notice that one of the ratio doesn't have any detailed measurement. So we could actually pair these two to solve for angle C. So let's pair with that, and we're solving for the measurement of angle C first. Okay, So to solve for that, let's use the fundamental law of proportion or the cross multiplication. You will get 5 and you have sine 14 degrees. On the other side, you will get 7 sine angle C. And since it's angle C that we're looking for, we will divide this by 7 and divide the other side as well by 7. Or if you are already a master of the properties of proportion, you may not multiply 7 to here, but just to illustrate the fundamental law of proportion, we have this. So sine C can be computed as the result when 5 is multiplied to sine 14 degrees all over 7. But we are not solving for sine C, we're solving for angle C. To do this, the measurement of angle C will be computed as the inverse of this trigonometric function, arc sine of this entire expression. 5 sine 14 degrees over 7. Let's now use this calculator to solve for the measurement of angle C. Now, we will just, we should start first with this expression. So let's try to use proper notations, which includes parentheses. So you will have 5 and sine 14 degrees, close parentheses, divided by 7 equals, that's your result. Do not round it up. That's the result, which will be subjected to arc sine or sine inverse. Your answer equals to this answer. The measurement of angle C is very short, which is 9.95 degrees. So the measurement of angle C is approximately, this calculator, 9.95 rounded off into 2 decimal places, 9.95, you will use here degrees. That's too small, but it's still possible. Now this is our measurement for angle C. That's the first item that we are looking for. Next is, using that value, we could solve the measurement of angle A. So in order for us to solve the measurement of angle A, we simply apply the triangle angle sum theorem, which tells us that the sum of the 3 interior angles of any triangle, which also includes a big triangle, is 180 degrees. That means you are going to subtract given measurement for angle B, which is 14 degrees, from 180 degrees, also subtracting the solved value here of 9.95 degrees. So the measurement of angle A, we will not be using equality here because this value is already an approximated value. It will be approximately equal to the result. Using this calculator here, let's have 180 minus 14 minus 9.95 degrees. You will have a very large value of 156.05 degrees. Even if it ends in hundreds place of your decimal places, but since again 9.95 is an approximated value, still it would be approximated value. 156.05 degrees. That's for your second angle. So we are now done with all the angles, and we will now proceed to measurement of the remaining side A. To do that, we'll be using the pairing of these two ratio. Even if angle A is already an approximated value, we cannot actually create a process where we will not be using any. Because if we're going to pair this as well with the third one, C earlier is already an approximated value. So let's finish it like this. Let us increase a portion here to the right. So we could just simply cross multiply, but we know that sine A or angle A is already measuring to 156.05, 156, that's 6 0.05. It's 0.05 divided by A is equal to sine of 14 degrees over 7. So cross multiplying that, you'll have 7 sine 156.05 degrees is equal to A times sine 14 degrees. Then we divide both sides by sine 14 degrees. Divide here as well, sine 40 degrees. So the value of A is approximately, canceling it out, this entire expression. Let's input that final in our calculator. So you're going to have 7 times sine 156.05 close parenthesis to be divided by sine 14 degrees. So we have an approximate value of 11.75 units because this is actually a side measurement. 11.75 units. This ends our computation for the oblique triangle that is formed with these measurements. Let's try to look into the relationship of the sides and the angle measurement. Here, our largest angle is angle A, 156.05 versus 9 versus 14. That would mean side A should be the longest. So 7 is B 7, C is 5, and you will know that A is 11.7 units. That's the longest. That's correct. And looking into the measurement of the angles again, you will have measurement of angle C, which is the smallest angle, as compared to 156.05 and 14 degrees. C, being 5, is the shortest. 5 versus 7 versus 11.75. So again, please be guided. Before you could solve SSA oblique triangles using the log signs, please determine the number of oblique triangles that can be formed. Because if there are 2, we still need to look for or solve for the measurements of the other oblique triangle. This is for this video.